Okay, today we are going to be reviewing the power rule a little bit, and then we're going to start looking at the next rule that you have to learn, which involves composite functions, so functions inside of other functions. So we'll start at this first because eventually you're going to have to learn to distinguish between which rule you should be using in which situation, and so being able to compare them all is ideal. So let's go ahead and do some power rule ones first. So we're using the power rule to find the derivative of each of the following functions, first expressing it as a power function or a multiple of a power function. So basically that we want to rewrite it so that it has an x to some sort of power. And we've been practicing doing that already, right? Rewriting radicals or rewriting it when x is in the denominator, rewriting it with a negative exponent. So we're just going to do a little bit more of that. So first and foremost, we can rewrite this as 1/3 x to the 7th. And so then its derivative would be 7/3 x to the 6th. So not too bad, right? All right, let's go look at some of these other ones. So let's rewrite it first. So this is really x to the -4th. So when I find its derivative, I get -4x to the -5th, and then you can rewrite it in a way that we can actually evaluate it, -4 over x to the +5 in the denominator. In this one, we have the cube root of x, so that's secretly x to the 1/3. Its derivative would be 1/3 x to the -2/3, because remember, we're secretly doing, let's do a little note over here, 1/3 minus 1, oops, and then give it common denominators. So really, we're doing 1/3 minus 3/3, which is -2/3. And then now we can rewrite it as a nice derivative we could actually evaluate. So first, if you want to move it to the bottom, we can do that. So it's 1/3x to the +2/3. And then final answer to write it as a radical again would be 1/3 the cube root of x squared would be your final answer for that one. The only calculus part is just taking the derivative. Everything beyond that is just algebraically rewriting your functions. Let's see, this would be -3x to the -1st power, so its derivative would be +3x to the -2nd power, which would be the same as 3 over x squared. And then this one, we can rewrite it as 6x to the 3/4. And so its derivative, let's see, if I do 6 times 3/4, that's 6 over 1 times 3 over 4, I would get 18/4 x to the -1/4, I believe, and we can check that using our denominators, right? Common denominators. 3/4 minus 4/4, -1/4. Perfect. All right, so now let's do a couple of things. Let's reduce our fraction, so this will be 9/2. And then, oops, and then we can move it to the bottom, x to the 1/4. And now you can rewrite it using your radical. So it'd be 9/2, the 4th root of x. Excellent. So just a little bit of review with the different ways that you can use power rule to rewrite functions and then actually take the derivative. Now we're going to start looking at some composite functions. So for composite functions, h of x is what they're calling them. Given in the first column is a composition of f of g of x. Your first thing you have to be able to do is identify what's the outer function and what's the inner function. So like in this example, my radical is surrounding my whole x cubed plus 1. So my radical is the outer function and my inner function is x cubed plus 1. If you want to pause and try these now, that would be awesome. Otherwise, you can keep moving through it with me. So for this first one, number 1, f of x, your outer function, the thing that's surrounding everything else, would be an x to the 5th. And that makes my inner function my 3 plus sine of x. For the next one, my outer function that's surrounding everything else is tangent. And my inner function is 3x. This one's a little bit tricky, but it's helpful if you remember how to rewrite cosine to the 4th of x. We can technically rewrite this as cosine of x to the 4th power. So then that makes it a little easier to identify your outer and inner function. My outer function is actually x to the 4th, and my inner function is cosine. This means we do cosine times itself 4 times. For this one, my outer function is my exponential, my e function, and my inner is 5x minus 2. And for the last one, your outer function is natural log, and and then your inner function is 3x to the 4th plus x minus 5. So that's the first step in being able to do the dealing with composite functions and derivatives, is being able to identify your outer and your inner functions. So now we need to be able to compare and see whether we identify the product of two functions, the quotient, or the composition of simpler functions. And then we complete the second and third columns of the table. So basically, if you check off that it's a product, your first piece will be u of x, and the second piece will be v of x, and then you just label which pieces are which, right? So x cubed secant. For this one, I have cosine of ln of x, so that's actually a composition of functions. My outer function is cosine, and my inner function is natural log. Now that you've had two examples, you can go ahead and pause and try them. Otherwise, I'm going to keep working. For this one, I got tangent inverse of the square root of x, so that's actually a composite function. My tangent inverse function would be the outer, and my inner would be square root of x. For number 3 right here, this is actually a quotient, right? I have a function divided by another function. My upper is sine of x, and the lower is 1 plus sine of x, so you can use the quotient rule on that one. This one I have e to the x times cosecant, so that's a product. My first equation, or my first function, is e, and my second is cosecant. All right, got a couple more. I have e to the sine inverse of x. That's actually a composition of functions, right? My sine inverse is inside of my e function. So my outer is e to the x, and my inner is sine inverse of x. Oops, I never put parentheses around that. This one looks like a quotient, so my upper is 3 to the x, and my lower function is 3 to the x plus x. On this next one, product rule, because we have cube root of x times ln x, so my first function is cube root of x, and my second piece is ln x, and then I think we're done. Right? So this is just a little bit of a preview into what we're going to be working with next, which are composition of functions and finding the derivatives of those. So just being able to identify whether you have a product, a quotient, or a composition is going to be really helpful, so you don't apply the wrong rule in the wrong scenario, okay? So go ahead and pause here, and then you can move on to your next assignment.